Evergreen, we're going to do Chapter 7, Review Number 2. So there's going to be algebra review on your test. Make sure you can add fractions. And so before you can add fractions, they need to have the same denominator. And so since we have a 3 and a 4 as our denominator, I'm going to multiply the opposite to each fraction. So we're ending up with 3x over 12 plus 4x over 12. And so when we add this, we get 7x over 12. Okay, we also need to multiply fractions, and so we are going to multiply 3 times x plus 4. When we do that, we're distributing 3 times x and 3 times 4, which is 3x plus 12. And then our denominators are 4 times 5, which is 20. Here, we cannot reduce because 3 is not divisible by 20, and so therefore this is our final answer. Here we have fractions being divided. 1/9 divided by 9 over a. Now, we never divide fractions. We are going to flip and do the multiplying by the reciprocal. So we're going to have 1/9 times a over 9. So we do our numerators 1 times a, and 9 times 9 is 81. Of course, we're going to get rid of that 1 and have a over 81. Next, we're going to subtract fractions. Now, this one is quite complicated at first glance. So we have 2g plus 2m divided by g squared minus m squared minus 1 divided by g minus m. So what I'm going to do first is factor this g squared minus m squared. When I do that, I copy everything else down exactly. And so I have g times g would get me g squared, and this is basically factored. This turns into g plus m and g minus m. Now, before we can add or subtract fractions, we have to make the denominators equal. Right now, they're only about half the same, correct? Yes, so we are missing the g plus m multiplied. So we're going to multiply both the numerator and the denominator by g plus m. And now we have the same exact denominators. We have g plus m times g minus m. Okay, and so we're going to distribute that 1 times g and 1 times m, which just gives us g plus m. Now we have the same denominator, and we can subtract. So 2g plus 2m minus g plus m would give us just 1g and 1m over gm times g plus m times g minus m. And so therefore our top and our bottom, we have some things that can cancel out and simplify, and we are left with 1 over g minus m. This is our final answer. You will have a question like this on your math test. Okay, so a parallelogram is a quadrilateral, all of whose angles are equal. So we need to know that the angles are equal in a parallelogram that is like a rectangle or a square. A parallelogram has opposite equal angles. So this is something you need to know. Opposite angles in a parallelogram are equal. Opposite sides are equal. A rhombus has diagonals that bisect each other, and when they bisect each other, since it is a rhombus, it bisects it perfectly perpendicularly with 90-degree angles. A trapezoid is a quadrilateral that has exactly one pair of parallel sides. So the bases are parallel, and the legs, in this case, are equal. They're not always equal, but the bases are always parallel. The opposite sides and opposite angles of a parallelogram are equal, just like we talked about earlier. Opposite angles equal, opposite sides are equal. The diagonals of an isosceles trapezoid are equal. So isosceles trapezoids are special because they have 2 equal legs, and if they have 2 equal legs, therefore their diagonals are equal, and their base angles are equal, and their top angles are equal. Let's look at this question. So if you can imagine a pop-up book and cards operate by means of parallelograms. They are folded when their book is closed, and as you flip the page, it opens this parallelogram and lifts the picture up to make it 3D. So the pop-up parts are kept parallel to the page as it moves by means of tabs, such as one shown in this figure. And so each tab is constructed so that, just imagine this parallelogram moving, squished and closed, and then moving up and squishing and moving up. So you can imagine these angles changing, but the sides are staying the same length. AB is equal to DC. AD is equal to BC. And so therefore we know that we are dealing with opposite sides that are equal. Two sets of opposite sides that are equal. And so a quadrilateral is a parallelogram if the opposite sides are equal, right? That's how we know this is a parallelogram. AB is parallel to CD. AB is parallel to CD, our two top and bottom lines. Well, the opposite sides of a parallelogram are always going to be parallel. If I gave you this quadrilateral and I said solve for x, could you do it? Do you know how many degrees are in a quadrilateral? 360. And so therefore we could add all of our known angles and we could solve for our x, which would be 59. If I gave you this one's a little bit more strange because there are no numbers, but we could solve it. We could write in a little equation to solve each angle. So if we were looking for A, first of all, let's start with what we know. A, B, C, and D equal 360 because they are the angles that add to this quadrilateral. And so if we were looking to isolate A by itself, we'd move B over and C and D on the opposite side of this equal sign. And when we did that, we would do the opposite sign to subtract them. And so therefore A equals 360 minus B minus C and minus D. And we could do the same thing for angle B. And we could do the same thing for angle A and for D. Now for E, this is an angle that is created by two lines, and this actually makes a triangle. Do you see that? And within this triangle, we know Y and X and E. These three angles will add to 180 because they are our triangle. And so therefore, if we were trying to get E all by itself, we know that E would be the same as 180 minus X minus Y. So on your test, you'll need to be able to write little expressions and equations to solve for angles. Even when you have no known angles, you should be able to tell me what angles to add from a total, either of a quadrilateral or a triangle. Now, what shapes do you see in this tangram? This one's just kind of for fun. So we see triangles, 1, 2, 3, 4, 5. We see quadrilaterals, which are four-sided figures, 1, 2. We see one square. We see 0 trapezoids, individual trapezoids, but we'll come back to that one. And we see one parallelogram, this yellow parallelogram. Now, if we're looking for little trapezoids within this huge figure, we can definitely take the whole figure at itself. That's 1. And then we can look and see, we could add some here. This yellow and red together make a trapezoid. This green and purple make a trapezoid. Do you see that? This purple and pink make a trapezoid. This pink and orange make a trapezoid. And so these are just fun things you can kind of look and try to find trapezoids and parallelograms within this figure. Okay, now remember, a mid-segment of a quadrilateral is found by adding one top base plus the bottom base and dividing it by 2 for the mid-segment of a parallelogram, or a trapezoid, sorry. And so therefore we'd have x plus 2 plus x plus 12 all divided by 2 equals 10. We're going to simplify this and make this 2x plus 14 divided by 2. And then we're going to reduce these fractions to make it x plus 7 equals 10. We subtract 7 from both sides, and we get that x equals 3. So therefore our top would be 3 plus 2, 5. And our bottom base would be 3 plus 12, which was 15. So therefore we have 5, 10, 15. Do you see how it's descending equally? Okie doke. Now, solve for x. This time we have a triangle with a bisegment. And so therefore we know that this bisegment is half of the bottom base. Okay? And so therefore we could solve this by saying the base divided by 2 equals 10. When we write this fraction, we can reduce it by x minus 3 equals 10. And then we can add 3, and we get x is 13. So therefore we know the base of this triangle is 13 times 2, which is 26, minus 6, which is 20. Now, is 10 half of 20? Yes, this is correct. 18. Solve for j. So the first thing I see here is we have a trapezoid. This is not an isosceles trapezoid because these two sides do not appear and they're not marked as equal. And so therefore it's a scalene trapezoid. And so we know that a total of 360 degrees is inside of this, correct? Yes. We also know that two linear pairs or two adjacent angles will add to 180. Now, I know these two will not add to 180, and I know that just by looking. Do you see how this is an obtuse angle? And this is an obtuse angle. So therefore, we know that 104 and j will add to 180. These are the two adjacent angles that will add to 180. And so when we subtract 104 from both sides, we get 76. We know that j equals 76. And if we wanted to just double check this, we know now that 27 degrees, and right here, this missing angle is 180. And so therefore, we know that this missing angle is 150. And so therefore, we have 153 plus 104 plus j, which is 76, plus 27 degrees, all equals 360. We have done it correctly. You're so smart. I hope you're doing great. And if you have any questions, send me an email because next time I see you, we're going to be doing our test. Bye.